Now I'm going to give you the graph, and you're going to write the open sentence using the absolute value. I know in the last lesson or two we would write the equations to match the graph. Now we're going to write absolute value equations. And this can be done in 2 easy steps. Okay? Step 1 is find the midpoint. So I have a dot at 3, I have a dot at 9. Anytime you want to find the midpoint, you would add the 2 numbers together and then divide by 2. So 12 divided by 2 is 6. And I realize many of you would have just known that by looking, but that may or may not always be true. So my midpoint is 6. We next need to then find the distance from the midpoint to the end point. Find the distance from the midpoint to the end point. So 6 to 9 is 3, just like 6 to 3 is also 3. You will always have the absolute value of x minus, in this case it will be 6, the midpoint, and then we would have our end point. Now, when you look at this graph, what I see is we just have a dot at 3 and a dot at 9. Nothing shaded right or left. So what that represents, in this situation, we would have an equal sign. If I solved this equation, I would get a solution of 3, and I would get a solution of 9. Nothing to the right, nothing to the left of that. So we're going to repeat the process. Step 1, we need to find the midpoint. So I have 15 and 26. To find the middle of something, I would then divide by 2. If I add that together, I get 41. 41 divided by 2 is 20 and a half. So my midpoint is right here at 20.5. Next, I will have to determine how far the midpoints are from our end points. Well, to get to 15 to 20 is 5, and then a half more, this would be 5.5 away. To get from 21 to 26 is 5, plus that half, that would still be 5.5. So x minus my midpoint of 20.5. The distance to my end points is 5.5. Now again, I have just 2 dots here. I do not have shading left or right, so that tells me this is an equal situation. Okay, now we have some that have shading. What I'm noticing is we have shading here, we have shading here. What kind of math problem was this? Is this an and situation? Is this an or situation? Hopefully you are thinking or. All right. In our last set of problems, what kind of inequality sign did we use to get OR answers? Hopefully you're thinking about greater than. Turn back one page in your notes if you need to. But the process remains the same. I'm going to find the midpoint between here and here, so -5 plus a -1. Oops, I guess I should finish. Sorry, is -6 divided by 2, -3. Determine the distance from the midpoint to the end points. It is 2. Remember, we talked about distance is always positive, even though now we're working in the negative area of a number line. They will be positive. So, the absolute value of x minus our midpoint, -3. We have open circles, and we know it's OR, so we're going to use greater than the distance from our endpoints. Again, when we're working in algebra, we do not do minus a negative number. I'm going to ask that you would write x plus 3 in the absolute values greater than 2. We have one more to go. Finding the midpoint. 1 plus 9 divided by 2. 5 would be my midpoint. Determine the distance from the, whoops, made my arrow a little long, but that's okay. Determine the distance from the midpoint to the endpoint. In both cases, it is 4. Okay, do we have an AND or do we have an OR situation? Because I have shading towards each other. This would be AND. ANDs are less than, but in this case I have solid circles, so less than or equal to. So the absolute value of x minus the midpoint of 5 is less than or equal to 4. Now, let's say it is a quiz or test time and you can't remember if it's less than or greater than. You could very, very quickly just test it and solve. I could do x minus 5 is less than 4. X would be less than or equal to 9. Following what we were doing in the last one, I'd keep my math problem the same. Opposite inequality, opposite answer. Add 5 to both sides. And I would get x is greater than or equal to -1. If I just took my answers here, sketched them on a graph, I need x's less than 9. I need x's greater than -1. I know that I picked the right inequality sign here. You can always test it to see if it matches your graph.